Hi, so let's discuss the implementation for counting sort algorithm that we have just seen. So I'm to complete this function, I'm given this array, and what we will do, we will first find out the largest element so that we get to know about the range. So that is easy. We just need to iterate over all the elements, and we can assume that all the elements are, let's say, positive. Then I can say the largest is -1 by default, and if I want to find the largest element, then I will say okay, largest is maximum of array of I and largest, so this will give me the largest element. Okay, then I will create a count array. Okay, I can also call it as a frequency array, so int star frequency, and I'm going to create a dynamic array in this case because we don't know the size in the beginning. So this is how we create a dynamic array, and it is of the size largest plus 1. Okay, so if the largest element is 8, we at least need 9 elements in this array, and we are going to initialize it to 0. Okay, so another way of creating this array is we can use a vector as well. Okay, so vector is a dynamic array, so I can say vector of integers, I call it as frequency. And if you're not familiar with vector right now, there is a module on vectors in this course which you can watch later on as well. Okay, so I'm going to create a vector. It's a dynamic array. It is going to have a size of largest plus 1, and all the elements are going to be initialized with a value 0. Okay, and then what we are going to do, we are going to update the frequency array. So I can iterate over the original array for int I equals to 0, or I can say for int x that is there in the original array A. So I can say frequency of this particular element x, this should be incremented by a value 1. For example, you see a 5 here, so you see, okay, this frequency of 5, which is initially 0, this should be incremented by a value 1. Next time maybe you again see a 5, so this should be incremented by a value 2. So x is something that is present in the original array. Now we have the frequency vector ready. Okay, so our final step is we have to put back the elements from frequency array into original array. Okay, so for that, what we will do, we will say, okay, I will take two variables, one, let's say j, that is initially 0, and another variable that I will take to iterate over the frequency array. So I can say I equal to 0, I less than equals to largest, I plus plus, and what I can do, I can put a while loop while frequency of I is greater than 0. Okay, so we are going to, let's say we come to this index and we see there are 2 times 1, so we can say while this frequency is greater than 0, extract 1 out of this. So we put a 1 here, we take a variable j that is for the original array, and we do j plus plus, j comes here, and we also reduce the frequency at the same step. Okay, so treat it like we are removing elements from this count array. So first element we remove the frequency by 1 and put it 1 here. J moves to the next index, and next time we again see this is not 0, we reduce it the frequency to 0, we put a 1 here, and we move on to the next index in this original array. Okay, so we have to do 2-3 multiple steps. We have to copy back the element in the original array at the jth index, and that element is equal to I. Okay, that's what we know. Then we have to say frequency of I minus minus. Okay, so we are using I to iterate over this array, and frequency of I denotes this frequency. This is reduced by a value 1, and j, which is a pointer, which is a variable that denotes till what index we have filled the elements in the original array. So this is j, so let's say we have filled till the second index in the original array, so we do j plus plus here. Okay, and that's it, and from this function call we just return. Okay, that's it. So now we are getting some errors. That's because we have not included the header file for vector, and so okay, so this seems like a problem because this array is actually a pointer, it's not an array, so we can't put a for each loop on this array here like this. So we have to do our manual loop for int I equal to 0, I less than n I plus plus, and we have to do frequency of array of I plus plus. Okay, so this is another way to write the same code, and now it seems we are good to go. And let me try to run counting sort. So if you look carefully, we are getting an array that is a sorted array for the given input. That means our code is working perfectly fine. Okay, now the only thing that you should know is what is the complexity of this loop. This loop works in order of n time, and if we talk about these two loops together, it may seem we are using two nested loops, but for certain positions we are doing order 1 work, and for certain positions we are doing more than order 1 work. Okay, but if you talk about in total what we are doing, let's say we have n elements in the array, let's say we have 8 elements in the array, let's say 2 elements were here, 3 elements were here, and one element was here, and let's say 3 and 2 5 or 2 7, and let's say one element was here, and let's say this was 0. So what we are doing, we are going to this position, we are emptying the array. So at this position the loop will run 2 times, here it will run 1 time, here it will run 3 times, here it will run 1 time, and here it will also run 1 time. So 3 plus 2, 5 plus 3, 8. That means in total, in the worst case, after doing all the subtractions combined with this for loop, this loop will not run more than n times, plus there would be few boxes which are part of the range, but they don't have any output in between them. Okay, they are 0, so we may iterate a maximum of range as well. Okay, so this comes out to be order of n plus range. So this is the complexity of the counting sort, and you can see it looks like a linear complexity. That means for certain problems where you have data that is bound in a particular range, you can also use counting sort over inbuilt sort. Okay, so that's what I wanted to tell you in this lecture. Thanks a lot for watching.